Hello guys and welcome back to Mr. EduFox TV. In this video we want to be breaking down implicit differentiation, which is differentiation of implicit functions. So before we do that, we first have to remind ourselves of explicit functions. So we have these two types of functions. You have explicit functions, which is what we are used to. Explicit functions, these are functions which are in the form y equals to a function of x. So y is isolated. Y is isolated. You have y on one side and then you have a function of x on the other side. For example, if you have a function like this, y equals to 2x squared plus 3 ln x, right? So on one side you have y, which is isolated. Let me use this purple color. On one side you have y, then on the other side you have a function of x, as you can see, function of x. So y is completely isolated. Y is isolated, meaning y is the subject of the formula, right? Now in this case it's easier to find dy over dx. It's easy to find dy over dx of this function, you see, because y is isolated. However, when it comes to explicit functions, when it comes to implicit functions, right? In this case, implicit functions, f of x, you have f of x and y equals 0, or you can have g of x and y equals to h of x and y. So as you can see, this is a function where y is not isolated. Y is mixed with x and y. The function is x and y mixed together. For example, if you have a function like this, y cubed plus x squared equals to 4xy plus y squared minus 0. If you look on the left hand side, you can see you have a function of x and y, and if you look at the right hand side, you also have a function of x and y. So you have x and y mixed together. You have y, you have x, you have y, you have x, all of them mixed together. You see, this is an implicit function. So in that case, sometimes you can make y the subject of the formula, and other times you just cannot make y the subject of the formula. So what do you do in that case? You can differentiate this function by differentiating both sides, and this is called implicit differentiation. So the first step of implicit differentiation is to differentiate both sides. So if you have g of x and y equals to f of x and y, right? You can take the derivative of both sides. You can take the derivative of g, x, and y equals to the derivative with respect to x of f of x and y, right? And then this is what I call step number one. Step number one is to take the derivative with regards to x and y, take the derivative on both sides. Step number two, I'm going to write it here, is to isolate dy over dx. This can happen by taking the common factor, taken as common common factor. You'll see once we do this. So these are the two steps of doing an implicit differentiation. We're going to take one example now. Let us look at one example. So example number one, I'm going to write it here. Number one, you have x squared plus y squared equals to tan y, right? Before I do this, I do have to explain that whenever you take the derivative with respect to x, right, of y, for example, let's say you have y to the n, right, you are going to normally differentiate it as if you are differentiating x. But because it's a y, you have to multiply by dy over dx. So this one, you're going to take the power rule. You're going to say this is n, y, n minus 1. Then you have to multiply it by dy over dx, right? This is very, very important. So, example, if you're taking d over dx of y cubed, for example, this is going to be 3y squared multiplied by dy over dx. That is how you differentiate y, because y itself is a function of x. So let's do another example. Let's say you have d over dx of sine y. This is going to be what? We take the outer function, which is cos y, then we multiply it by dy over dx. This is what you have to do every time you're differentiating something that contains y. Now let's go back to our example. Example number one, we have x squared plus y squared equals to tan y. First step number one, remember, you take the derivative of both sides. So you have x squared plus y squared equals to the derivative of tan y, right? So now we're going to differentiate each term. So to differentiate x squared with respect to x, we get 2x. Plus, to differentiate y squared, we're going to say this is 2y multiplied by dy over dx equals to differentiate tan y, we're going to say this is sec squared y from the table. Then this also you multiply by dy over dx because we are differentiating y with respect to x. Then step number two is this step over here, where we say we have to isolate dy over dx. So you're going to look for terms containing dy over dx. This term contains dy over dx. This term contains dy over dx, and you're going to group them together. So for me, preferably, I would say to the left-hand side. So you're going to take this one, you move it to the left-hand side, and this one, which does not have dy over dx, you're going to move it to the right-hand side, right? So on the left-hand side, you're going to have 2y multiplied by dy over dx. This is minus sec squared y multiplied by dy over dx, and this is equals to minus 2x. Then you have to take dy over dx as a common factor. You see, as a common factor. So we're going to say dy over dx as a common factor. You have 2y minus sec squared y equals to minus 2x. Then the last step would be to divide by 2y minus sec squared y, divide by 2y minus sec squared y. Then this will cancel that one. Then the final step is dy over dx equals to minus 2y all over 2y minus sec 2x minus sec squared y, and you are done. You have officially and finally found dy over dx. You have differentiated this function. You have differentiated this function the question would be find dy over dx. And here we found our dy over dx. So let's try and do another example. So example number 2. Example 2, we have let me see. Yeah, we have 2x cubed multiplied by y squared minus sine y equals to 4. As you can see, this is an implicit function. X and y is mixed together, and y is not isolated. Therefore, it is an implicit function. So we need to apply the implicit method of differentiating to find dy dx. So the question will be find dy over dx. So what do we do? Step number 1, differentiate both sides with respect to x. So we differentiate 2x cubed y squared minus sine y equals to d over dx of 4. Right? Now, let me write this one properly. This is 3. Now, we want to differentiate this term over here, right? Now, if you look at this term, you have a product of two functions. The first function is 2x cubed, and the second function is y squared. With the product of two functions, we use the product rule, which tells us that we can differentiate the first function. Let's call it the purple function, function 1, which is purple. We differentiate it and we leave y squared as it is, meaning the second function as it is. So we're going to differentiate our first function, which is going to give us 6x squared multiplied by the second function, which is y squared, plus now we differentiate y squared, which is what? 2y multiplied by dy over dx, and we multiply it with the first function, which is 2x cubed. Then we are done. Minus, this minus is this minus over here. This minus is that minus. Minus sine y. So now we have to differentiate sine y. Differentiating sine y is going to give us cos y multiplied by dy over dx. Every time you differentiate something that has y, you multiply it with dy over dx. This is equals to 0. Differentiating a constant gives us 0. Then we look for terms containing dy over dx. Here's our first term that contains dy over dx, and here's our second term that contains dy over dx. Then the ones that do not contain dy over dx, we isolate, we take them to the other side. And these ones, we leave them on the left hand side. So the left hand side, you'll have, let me use a blue color. The left hand side, you'll have to, let's multiply this. Let's multiply this guy and this guy. Let's multiply them. So that will give us 4 4x cubed y multiplied by dy over dx minus cos y multiplied by dy over dx equals to minus 6x squared y squared, right? Minus 6x squared y squared. Then we take dy over dx as a common factor. We say dy over dx as a common factor will give us 4x cubed y 4x cubed y minus cos y. This is equals to minus 6x squared y squared. Then we simply divide by 4x cubed y minus cos y, 4x cubed y minus cos y. Then this will cancel that. Then our final answer will be dy over dx equals to minus 6x squared y squared all over 4x cubed y minus cos y, and we are done. This is how you do implicit differentiation. Now let's look at the next example, example number 3. Example number 3, this will be our last example. Example number 3, we have x sin y equals to y sin x. So this is an implicit differentiation function, and you cannot isolate y, or y is not isolated. So in this case, we do what we've been doing, take the derivative of both sides with respect to x of x sin y equals to the derivative with respect to x of y sin x. Then you can see on the left hand side we have a product of two functions. We have function y over here and function 2, and we're going to use the product rule to find the derivative. So we're going to differentiate the first function, which is 1, and we multiply it with the second function, plus we differentiate the second function, which is sine y, so it's going to give us cos y. This one you have to multiply it with dy over dx, multiplied with the first function, right? Then this is equals to, on the other one we have function 1 and function 2, product of two functions. So we take the derivative of y. The derivative of y is just 1 multiplied by dy over dx, which can just be dy over dx multiplied by the second derivative, plus the derivative of x of sine x, right, which is cos x multiplied by the first function, which is y. Now, once we get to this stage, we now look at terms which contain dy over dx. So here's the first term, contains dy over dx. Here's the second term, contains dy over dx, right? So in that case, what do? We said preferably let us take all terms containing dy over dx to the left hand side. So we're going to take this one to the right hand side, and this one we're going to take it to, to the left hand side, and this sin y we take it to the right hand side. So this is going to be rewritten as cos y, let me put that x over there, dy over dx minus dy over dx sin x. This is equals to cos x y minus sin y, right? Let me put a bracket here, minus sin y. Let me put bracket here to show that this dy over dx is not part of the y. Rather, cos y as a whole is multiplied by dy over dx. So now that we have isolated dy over dx, we can take dy over dx as a common factor. dy over dx gives us cos x cos y minus sin x. This is equals to, let me write it as y cos x minus sin y. Then we divide by x cos y minus sine x, divide by x cos y minus sine x. Then this cancels that one. Then we found our final answer, dy by dx equals to y cos x minus sine y all over x cos y minus sine x, and we are done. This is how easy it is to find the derivative when dealing with an implicit function. This will be part 1 of implicit functions, and I'm going to do part 2 where I tackle more examples. So be on the lookout. Please subscribe so that you don't miss it when I post the other videos. Please subscribe, share the video, like the video, comment any questions you have, any comments you have, put them on the comments, and I'll see you guys on the next video.